Alright, yesterday we got through, was that problem 14? 15, 16? 15?
No, 16.
Yes.
18. Oh, wait, we got through all the way to 18.
Are we at 18?
Yeah, we just finished 18. Yeah.
Sweet. We ended by talking about some like the relationships between the different trig functions, or not trig functions. Maybe that's class. Talking about the different relationships between the formulas from geometry, like surface area and volume.
For two quick announcements. First of all, teachers, there are cold freeze dries in both of the lounge and the workroom refrigerators. So help yourself. And so a soda or a tea, whatever's in there.
Oh, that's kind of cool.
And seniors, your Santa pictures are back. And we will have them out at lunch on the table. So come by and pick up your Santa or Grinch picture.
Yeah,
Right? Okay, so I refer to these as very change problems because they're modified versions of the simple formulas we've been talking about. We have different variables. A lot of textbooks refer to these related rates, so I made sure to include that definition in there too when we talk about our notes. So let's continue. 20. Depending on the formula or depending on the problem with difficulty of it, ways they can make it easier, they give you the formulas. Ways they can make it harder, they don't. You remember that. So let's look at 20 and talk about the following piece of information. The formula for the volume of a cone is V equals 1/3 pi r squared h. Find the rates of change of the volume if dr dt is 2 inches per minute and h equals 3r when r equals 6 inches and when r equals 24 inches. So, we're talking about these problems. There's a couple basic steps you can do every single time. Step 1, a picture is helpful, not always required though. Step 2, once you have that picture in mind, the other pieces that you might want to do is know the formulas in question. Depending on the equation of the problem, they may give you certain formulas or pieces. You may have to find some depending on what's known. And the third one is develop an equation using the parts you have so you can try to find that exact specific piece we want. So I want to point out a couple of things in this problem. Really important pieces. What are we looking for? The rate of change of the volume. That's our long-term goal. In terms of what we've talked about so far, there would be dV dt. What have they told us so far? It's the volume of a cone, which again is a formula. That would be nice, especially if you don't remember it. It says dr dt is 2 inches, and it says h is 3r. We have two known values that we're trying to check. R equals 6 and R equals 24. Using those pieces, let's figure out how this thing's going to fit together. First, I'm sorry, we're drawing a picture. Beautiful. So I'd have R, and I have H. So I have that V equals 1/3 pi r squared H. I know that dr dt is 2 inches per minute. H is equal to 3r. And I want to find specifically what happens at r equals 6 and r equals 24. How is the volume changing? All right. So far, first few steps done. Step 3. We have 4 ways to find an equation we can actually take that and solve. So, our long-term goal is to find the change of the volume, so dV dt. So we want to make sure to use the volume formula as the main formula in this problem. 1/3 pi r squared h. Since it has two variables, r and h, we're going to derive implicitly like last week. Unless we can find a way to modify this equation somehow. From 2 variables down to 1.
Look at H.
Look at h. So we know for a fact that h is equal to 3r. So we're going to take this top equation, we're going to plug in everywhere there's an h of 3r, and see what happens. V, 1/3 pi r squared h. Instead of h, 3r. This becomes pi r cubed. One equation, one unknown, and long term, I know I'm going to eventually get dr dt, which I have as a known value. and I have R in the problem, so I'm going to be able to plug all those two pieces in. I could, if I wanted to, get this in terms of H instead of in terms of R. All I have to do is solve for H and then plug that in instead. Or solve for R and plug that in instead. I choose to plug 3R in for H because everything I have is in terms of R, so my formula better be in terms of R. Again, it's a different modification I could do if I chose to. Let's continue to our next step. We're going to take a derivative. Since this is a related rate problem, I'm going to do it with respect to t. So, easy thing, left-hand side, what's going to happen? dv dt. The derivative of a single variable like x becomes a 1, but because it is with respect to t, it becomes dv dt. On the right-hand side, we have pi r cubed. Pi is constant, unless you're Ricky. I'm not going to let him forget that, ever. Is pi constant? Okay, pi is constant, so let's talk about the r cubed. If pi was not constant, we'd have to do a product rule. That's why I make sure to emphasize that point. R cubed. How about a derivative of r cubed with respect to t? Derivative of r cubed with respect to t.
3r squared dr dt. And the pi is constant, so just run out.
That's right. Derivative of r cubed is 3r squared, but because we're taking r with respect to t, we get a dr dt to pop out. This is good, because we know what dr dt is. Dr dt is 2. So let's make a change. And where there is a dr dt, we're going to replace instead with the number 2. So 3 times pi is, of course, 3 pi. R squared is r squared. Dr dt, plug in 2, times this by 2. So I end up with 6 pi r squared. Got it working? Sweetness. Thanks, man. Much appreciated. All right. Next thing. I've got the formula. This is what I need for this problem. So my next phase is I want to make sure to figure out what's happening at 6 and what's happening at 24. So I plug those two numbers in. First piece. dv dt at 6. So I plug 6 in for r. So I have 6 pi times 6 squared. I end up with 216 pi. This would be in cubic inches per minute because the volume is what we're taking the rate of change. So in cubic inches, so the problem is in inches. Minutes per minute because the problem is in minutes. For 24, same process. dv dt at 24. A little bit tougher. 6 pi 24 squared. So that would be
Faith in you.
I would never have faith in me. 864 times 4, so 33. 12?
864?
33, 12, 5.
What'd you say 24 squared was?
What'd you get?
3,406.
Yeah.
This is the other one. Dang it. 3,456? So 3, 4, 5, 6? 5?
That's not weird enough.
No, I'll be honest with you. What I did was I took 216 times 4 times 4. And I failed. It happens. Okay. Questions? So we took the function in the problem. We have to first recognize what we're looking for in the long term, dv dt. We're able to take the formula and make adjustments to it. If we couldn't make those adjustments, we could still do this problem. We would just end up with a dh dt as well, which would end up in our solution somewhere, which is fine. Don't assume that every answer is just a single number. Your answer could be a formula that somebody else needs. Okay? Let's look at 22. 22. Oh, for the picture? You might have wondered why I put the cone this direction. So I could have obviously put the cone the other way. Because think about it, if I am filling up a cone, like I have cone stuff in here,
I guess cone stuff. Like the charge of the cone.
right? I could obviously fill it the other way. I could flip this thing over and fill it the other way. There becomes a small problem. Like, depending on how I do it, I could end up having two consequences. If I think of this as a solid cone being filled, I have to do it this way. If I think of it like dropping like sand onto the floor, if you ever like drop any kind of pebbly object, it creates a cone-like shape. That I could do. But if I think of it as a solid shape, it doesn't work. Because I'm filling up a solid cone. When I fill it up, it will actually not form a cone. It would form a weird disc shape. So like how I draw this picture could matter. But again, I don't need the picture to do this. So the picture part is always optional. But it can give you better understanding of what's happening on the problem if you're not sure. So, 22. A conical tank with vertex down is 10 feet across the top and 12 feet deep. If water is flowing into the tank at a rate of 10 cubic feet per minute, find the rate of change of the depth of the water when the water is 8 feet deep. Let's talk 22. I love these ones. These are fun. Okay. What are some pieces we need? Some pieces we know from the problem. Think of this like an ACT question. Find the important stuff. Cone. Conical, right? Cone. What else? Vertex down, so just like my picture up there. He said it was 10 feet across. 10 feet. And 12 feet. So he says right here, radius of 5. Water is flowing into the tank at a rate of 10 cubic feet per minute. Okay, what's that mean? dBdt equals 10. Very nice. How do you know it's dBdt, not dHdt or dRdt? How do you know it's dBdt? Because it's cubic. Right there. Cubic means volume, so it's got to be dBdt. Other things, you could think about it logically and be like, okay, water's flowing in, what's that going to change? Well, the rate it flows in is a volume problem. So you can't kind of logic your way through, but the best way is use it. Use the units. Units are helpful. Okay, what does it say to find? Find the rate of change of the depth of the water when the water is 8 feet deep. Rate of change of the depth of the water when the water is 8 feet deep. Thoughts?
We can really just use the SDT converters at the end so that we don't have to go through it.
Say it again. Sorry. I heard it and then my brain was like, no, you didn't hear that.
Couldn't we just use like dxdt and then at the end solve, like just plug it in for when it equals 8?
I could not do that because I'm trying to find the rate of change. So this is the question mark. What does it mean that says when it is 8 feet deep? We will eventually, yes. What does this statement mean? When the water is 8 feet deep. There we go. So when the height equals 8.
I was like, wait,
Yeah, but-
what does it tell you that for?
Yeah, that's.
I was confused. Like, wait, is there?
And that confusion is part of the kind of problem that these come into, is you have to be able to figure out how to interpret this information, because I want to put it in a formula, right?
Yeah.
My long-term goal is formula. So think about what the volume formula I'm going to use is. It's the 1/3 pi r squared h, right? So I would need to know either r, h, or dr dt, or dh dt. So it's got to be one of those four things. I know it's not dv dt because I already have that. So my bigger question should be mentally, which one of those four categories is going to try to fit into? Where is A going to go? All right, let's set this up. You'll notice that like problem 18 gives you the volume of a cone, and then future problems don't bother giving it to you. Because they assume that you're going to use the information from 18 to solve the other ones. I assigned all the odd problems. Check the even problems for some formulas if you may need them. Sometimes they are given. All right, 22. We have V equals 1/3 pi r squared h. We know dv dt is 10. We know. We want to find out the rate of change of the depth. So dx dt is a little confusing. Oops. Dx dt is a little confusing here. I could either use like depth for both. I could use x for both, or I could use h for both. But this is the depth as well. So if I'm going to call the depth h for height, I should make this dh dt. I hope that's clear. Because if I use dx dt, then what I want to do is I want to have this problem have x in it somewhere. Otherwise, how am I going to get dx dt? Now I could have x be the height. I would just have to make that the case. So either these need to both be h's, or they both need to be x's, they both could be d for depth. It should be the same thing though, because they're related. Alright. So you want to find h is equal to 8. We're going to find dh dt. Alright. One small problem. This formula, which is the one we're probably going to use, as we recommended, has h and r in it. On the previous problem, I had a nice little system that linked h and r together. That system was h equals 3r. So I could take this formula and convert it to one single variable. I don't have that right now. I have two options at this point, and this is where we can have notes today. Two options. You could just use the two variables and see what happens. Hopefully one of them gets fixed somehow. Looking ahead, I know that's probably not a great choice. All I have is dv dt as a known. I'm looking for dh dt. I have nothing for dr dt.
Have R. Don't we just plug in the R and just leave the H there?
Ah, this is r at the top.
R at the top. I was thinking like, with that, so it doesn't affect it, okay.
Mm-hmm. That 5 is r at the top. We are at the height of 8, so we're only about 2/3 of the way up.
Alright.
Good catch, because that was going to become an issue later on when we try to plug things in. I need to find a way to get this function to be entirely in terms of either r or h, and if I'm thinking long term, I probably want to choose h. Why? What I'm looking for is dh dt. So I need to find a way to take this function and convert the r's into h's somehow. Thoughts? You get algebra 1, algebra 2, and trig. How can we take this picture and this formula and turn it into just h's?
Did you plug in the H and just solve for dRdt and then do some algebra and find what that equals and then plug that back into the formula? Well, I'm thinking a lot of steps there.
That would work to find r and h, but it would not find dr dt. Dr dt would still be unknown. In fact, that will be a necessary step later.
Sure. I skipped too many steps.
Okay. I need to take this picture and somehow get it down to just R's and H's. So let me make a modification here to try to help out a little bit. In this picture, where we're at has H height and R radius. I'm going to erase this number for now so don't confuse the two. Adding in some more things. Inside a cone, you typically have a right triangle.
And the volume at H was 8.
GG, you look like you have an idea.
Well, I was gonna say you use the Pythagorean theorem to find
You good? You good? I'm assuming you're meaning like this piece. Right there. Or perhaps the longer piece right there. Either one you could. As it turns out, for the big triangle, it's going to get pretty messy here. I'm sorry about that. For the big triangle, it has sides of 5, 12, and 13. It does not tell me exactly what R and H are or how they relate to each other, but it does get me closer. I can actually use this if I'm clever. So take a look at the picture. I need a relationship between R and H. At a specific height, 8? No.
Yeah.
It'd be 3 1/3.
That's close.
Suppose.
Alright, ready?
No.
I'm going to pull something from geometry.
Oh, then yeah, no. Yeah, I would have never done that.
Take a look at this picture. Remind ourselves of something. This angle down here and this angle down there should be the same thing. Now I'm going to pull something from trig. If I have two triangles with the same angle, they will have the same trig relationships. Here's what I mean. In the big black triangle, tangent of theta would be equal to opposite 5 over adjacent 12. Now in the smaller triangle, which also has the exact same theta, it should have also a tangent relationship. That relationship would be tangent of theta is equal to the opposite for this triangle, which is R, over the adjacent to that triangle, which is H. You might notice that these both contain tangent of theta, and one of them contains R and H. I'm not going to use the property of algebra. If these two are equal to the same thing, they must be equal to each other. I now have an equation that contains both R and H. That's a big step. It pulls in multiple components from different pieces of mathematics. A trig property, a geometry property, an algebra property. But this is the logic of using these related rate problems. I have to find a way to connect these two together. Trig will connect them if I can see how. So again, from trig, these two triangles are the same in terms of their trigonometric ratio because they have the same angle. Because they have the same angle, their trig relationship from one should equal the trig relationship from the other. So 5 over 12 from the big triangle should match R over H from the small triangle. Or if you prefer, from geometry, you could use a similar triangle theorem. Even once I'm here, even if I get this far, I still have to take another step. Because I want to somehow figure out what R is. You cross multiply and divide, and I could use an algebra skill to get R by itself. Let's do it. We cross multiply. Good catch, Cindy. 5H would equal 12R. Now remember my long-term goal. I want to get H by itself. H should be the problem. So I solve for R. R would be 5H over 12. Now, everywhere there's an R, I can plug in 5h over 12. Meaning I get V is equal to 1/3 pi 5h over 12 squared h. Once we get here, I just have to square it, simplify, and then do the problem. This is very similar to number 20. But let's get to use a trig ratio to figure out the missing pieces. On 20, I was given the missing pieces. H equals 3R, or R equals 3H, whatever it was. This one I had to find them. This is what separates a difficult level problem from an easy level problem for the same material. On the easy one, they give me all the components, I just got to plug them in. On the difficult one, I have to go for searching. Now that we're here, let's simplify this off. 5h over 12 squared. How do I write that? Come on, I know it's been a tough one. 25h squared over 144 times h. Simplify again. 1/3 times 25h squared over 144, so the pi is going to stay a pi. 1/3 times 25h squared over 144, the h squared and the h squared are going to become h cubed. 25 over 144 times 1/3, I have 25 on top. And on bottom, 242? 432, I think. So now I have the volume in terms of h. I would suggest, if you have to add anything for your notes today, this trick will not be uncommon. Not necessarily that I'll use tangent, but that I may be forced to use an alternative formula to find a way to relate our two pieces together. If you look down here, I can see on 23, because of how these pieces are put together, I'm probably going to have to use some kind of formula to figure out how to relate the pieces together if I'm not careful. All right. Let's now actually start the problem. We got the formula, d dt. Left-hand side, dv dt. What happens to the pi? Constant comes out. 25 over 432. Times 3. H squared. dh dt. Oh, why'd I bother getting rid of that 3? This 3 is going to cancel with it. Okay. What is dh dt according to our problem? dv dt is 10. dh dt is what we're looking for. So, what else can we plug in? Our h is 8, so I plug in pi. 25, 432 times 3 times 8 squared. dh dt is still unknown. Remember, my goal is to find it. So my last step is going to be to get dh dt by itself. What do I need to do? Yeah. Could I simplify? Yeah, if I don't have a calculator, I'm probably going to simplify now before I bother trying to divide. If I do have a calculator, I could just push it all over and use my calculator to find the answer. I don't up here, so I'm going to simplify what I can. All right. 432 will cancel with the 3, leaving me with 144. 8 squared is 8 times 8. 144 cancels with one of the 8s, leaving behind that'd be 18. Another one can cancel, leaving me with 9 over 4. So on top, 25 times 4 would be 100 pi over 9. Sure hope somebody's checking my work. DHDT. And then I would divide to get DHDT by itself. I would end up with 90 over 100 pi. Let's hope. Or 9 over 10 pi. Sure do hope somebody checks my work. Yeah? Yeah. I love hearing that every day, AJ. Why don't you know that? Yes. Because how often I'm wrong, I love hearing that every day. Here we go. So, this part of the problem is standard. We've done this a few times already. Not too difficult. Some annoying basic math, you don't have a calculator, but you all should have one. You guys are old grown-ups. So we're here. The tricky part, here. Relating the pieces together. On this particular example, we were forced to use a trig function to relate two known values to two unknown values, then use an algebraic function to find and solve for one of them. One more time. We used a trig function combined with an algebraic function to write a relationship between the two knowns, 5 and 12, and the two unknowns, R and H. We then used an algebraic property to simplify that to where we have one of the variables solved for, the correct variable. It is very tempting to solve for R instead, or to solve for H instead. If that is the case, then you'll get down to the end and realize, oh, I can't plug in or find DRDT or DHDT. They have the wrong variable. Use what is given in the problem. Use what is given in the first two steps to guide you on which part of the formula is right. I could have solved this for H and plugged in H and found this with respect to R. That'd be a mistake because I want to find DHDT. I could have tried to solve this the way it was written using implicit differentiation, but that would have been a mistake because I don't know what DRDT is and I don't know what DHDT is. I'd be stuck. I have to take a step to combine the two together. Right there we did. I had to use the differential property to do it. Questions? Another example, perhaps? Yes, good. Good. What? Should we go to 24? Yay! Alright. A trough is 12 feet long and 3 feet across the top. See the figure. Its ends are isosceles triangles with an altitude of 3 feet. Water is being pumped into the trough at 2 cubic feet per minute. How fast is the water level rising when the depth h is 1 foot? B. If the water is rising at a rate of 3 over 8 inches per minute, when h equals 2, determine the rate at which water is being pumped into the trough. Okay? 24.
This wasn't close.
What should I do? I've already got a picture, so I need to get some formulas. What kind of formulas do I need? Volume of prism. Why the volume formula specifically do you know you need?
Cubic.
Cubic feet is a good indication it's using some kind of volume, so that would be a good idea. So I want to know, what is the volume of a prism? Specifically this prism. Anyone remember?
100.
That'd be the area of a triangle. That is the correct formula for the prism. Now, in geometry, I always taught capital BH, where B in this case represents the base area. So that'd be the 1/2 base times height. So I do. I don't want to confuse the two h's, so I will use length instead. So, for my triangle, to find the volume, I would do 1/2 the base of the triangle times the height of the triangle times the length of the trough. Volume is equal to 1/2 base, height, length of the trough. All right. I have 3 variables. Uh-oh. Can I get rid of these? Yes. You can. Because one of these is constant. Why is the length constant? It'll always be 12. When I pour the water in, it'll automatically settle the entire length as 12. It's not like slanted length. Okay? So length will always be 12. Length is always constant here. So, 12. Which means I have a formula that it contains B and H. My trig senses are tingling. I have to somehow connect together B and H if I want to be able to solve this problem, but let's go ahead and look farther down. Maybe something in the problem itself will give me some clues here. A. If water is being pumped into the trough at 2 cubic feet per minute, what does that statement mean? dBdt is 2. What the heck? Is 2. Okay? How fast is the water level rising when the depth H is 1 foot? Say again? H equals 1. What else? How fast is the water level rising? dH dt. Is what we're looking for, right? That's our question mark. Okay. So, I have H in the problem. I have dH dt in the problem. I have dV dt in the problem. In my formula, I also have B. None of what I'm given in this problem involves B. No. At the top, it's 3. But when I'm right here, you mean to tell me that's 3? If this is 3? But again, if I use implicit differentiation, because I have 2 variables, I'd have to use implicit differentiation. If I did that, I would end up with dB dt and dH dt. One of which I'm looking for, the other I don't even know. So that tells me very clearly, I can't have B in this problem. If I leave B in this problem, sure, I can figure out what B itself is, but I have no idea what dB dt is, or dB dt. I am missing that crucial piece. So I have to do the same thing I did on the previous one, find some way to relate together the B and the H. Some formula, some component that links these two.
Wouldn't it just be 1 because it's 3 feet at the top and it's 3 feet tall? And it's only 1 foot, so and it's isosceles. So it only be 1 foot across the bottom and on the side.
It would. But again, you found B. Do you know what dB dt is? Because if I don't get rid of B, watch what happens. Okay? Just watch. I'm going to do this quickly. 6BH. If I take the derivative with respect to t, I'd have to do the product rule because I have B times H. The 6 would pop out, so dV dt would equal 6 times the product. B times dH dt plus H times dB dt. You could tell me this one, you could tell me that one, you could tell me this one. I'd have 2 unknowns, 1 equation, algebraically unsolvable. So I pose to you, yes, you could find B. And you were right. That is B. I'm going to use a trig function again. There is no simple way to fix this without finding that relationship, and the way to do that is using that angle down at the bottom. All right. Only experience can teach you this. The first time you take this equation and you try to solve it, you will end up here if you do it correctly and be like, well, I'm screwed. Guess will that work? I have to go back and fix. Because again, I can't, I can do this. I can do this. I can do this. I can do this. 2 unknowns. Can't be done. So I have to find a way to get rid of either B or H. B is the best candidate because of what I'm looking for. I want to find H. Let's do it. Take this picture. I need to find a way to break this apart so I can find out how to fit my H versus my B into this problem. Say again?
Isn't that angle and the other angle equal?
Yes. So very similar to the previous problem. This is a common trick. So if you look at this picture, tangent of that bottom angle would be equal to the opposite, which in this case would be just a singular piece, 1.5 over the adjacent, the height, which the height in this case, 3. This would be equivalent to that same angle, the unknowns. So in this case, hold on, be careful. There's a trick here.
Anybody at Santa needed in the office for checkout? Anybody at Santa needed in the office for checkout?
It's all the way across. Half B. Even when it's similar to a previous problem, they want to throw something in there to twist on you. Okay? Make sure to match components. All right? We use 1.5 here because it was part of the triangle. We have to use B over 2 here because that's a part of the triangle. All right? Now we can submit each other. 1.5 over 3 is equal to B over 2 over H. Solve for H, cross multiply. So we end up with 1.5 H equals 1.5 B. How do I solve for, what is it, B I need to find? Yeah, how do I solve for B? What? What?
Right.
Wow.
Huh. So I just put in H for B. So everywhere there's an H, everywhere's B, I put an H. This means my volume formula would become 6H squared. Would there have been a faster way to do this from the beginning, by the way?
We already had we had 1 equals 1. We saw, we were given H and we already saw for B. We had brought it back and then we have to set those equal to each other.
Only if you saw it. Did you see it?
Yeah.
I didn't hear you say it.
I did say it because we were like, huh, where's this going to go?
And that's why we spent 5 minutes trying to go in a different direction.
Well, now
If only you had said it.
Now I know how to solve it whenever it gets to a point to where it's not as.
So, want to notice what it is you're talking about again? Look at our picture. The height is 3, the base is 3. What do you notice about those two numbers? They're equal. Will that always be the case in this picture? Yes. It says that's isosceles. That's actually a lie. Well, the height in this case is 3. The top piece is 3. And no matter how you put this, those two will always be the same. It has to be because of similar triangles. So in this case, B does equal H everywhere. So you're going to go ahead and finish this for me? Okay. What bases do we know? So what? Is what? Is one?
I know we have dVdt equals 2. We don't have dHdt.
So dVdt equals 2. H is 1, so 12 times 1. How would I get dHdt by itself? How can I put this in terms of words? The height goes up by 1 every 6 minutes. The change in height over the change in time. Now, if you can find a better way to relate the two components we need, you gotta go for it. Timidity will not serve you well on these math problems. You have to go for it. That's my suggestion for your homework assignment. We'll continue working some tomorrow. We'll be due at midnight tomorrow. Yay! I'm so excited.